Okay, good afternoon everyone. My name is Heitor Gomes. I'm yet another priest of the data stream mining church. I preach out of the Wellington University, Victoria University of Wellington. So Albert and Yun Singh already talked about this, but just to refresh your mind, when we are doing machine learning for batch data, we have these two phases, very well-known phases. You have trained data and you have the test data, and the output is a trained model, so you can put this into a function or and just deploy it in production. Now with streaming data, you have this trainable model, so this thing that is being trained and tested over time and keeps changing and might change as well. I'm going to talk specifically about partial delayed labeling. So in a happy scenario, you have that on the top, so you have x0 arrives, and then in the next time step, you have y0, so you have the class or the target value that you want to know about, and then this keeps happening. In some applications, this is true. Most often, this is not true. And then you have this delayed and varying semi-supervised scenario where some of the labels might arrive with some delay, and some of them will never arrive. So you need to decide whether you are going to use those or whether you are going to just dismiss the unlabeled data. Now in data stream mining, you have these two big challenges. You have the computational challenge because you have constrained memory and everything that you want to have predictions as fast as possible and train the model as fast as possible. I also have the other problem that are changes over time. So the distribution is unknown and it may change over time, which is called concept drift. Now in partially delayed data stream setting, then you have other challenges, like you need to learn from a limited amount of labeled data. You need to detect and react to the changes in the data, and you must avoid this catastrophic behavior, like when you're learning from unlabeled data, sometimes the bias of your algorithm might be off, then, or what the assumptions of the model might be off, so you might just get a worse model than you would get if you only had the supervised model being trained on the small amount of labeled data that you have. And you also need to adequately benchmark the algorithms. I don't have much time to talk about the benchmarking part, but I have time to talk about the parts of the rest. So what algorithms you could use in this case? You can have like cluster, then label. Those who are familiar with semi-supervised learning, you might know about this. You assume, you have the clustering assumption, so data that is close together in the space might belong to the same class. So you can kind of have this after you have some labels in a microcluster, you can just expand them. You can also do self-training, which is quite simple, so you just make the classifier train on itself. And sometimes it works quite well. It has some nice properties, like you can use any algorithm to do that. But sometimes it doesn't work very well because the algorithm was underperforming, for example. All of this works in a streaming setting. Now, one thing that is more interesting for data streams is concept drift detection. So when a concept drift happens, so the distribution of the data changes, something is off with the learning model. You might not be able to produce the same correct predictions as you were before. So ideally, we should be able to detect those changes even if the labels are delayed or they never arrive. And besides detecting, you might also want to do some actions like triggering automatic updates or maybe requesting new labeled data, or just informing users that this happened. To this end, we had a work in 2020, which was extended this year as well, doing this unsupervised concept drift detection using a student-teacher approach. The idea is very simple, like you have the teacher, which is the classifier that's actually making predictions and for your problem, and then you have the student, the one that is learning to mimic the teacher. And when the mimicking error increases, we hypothesize that it might mean that there was a concept drift, and then we can do all sorts of things like detect the change or just retrain the model. And that was it. Thank you. This is another survey. You were going to clap. Don't clap yet. I still have time. So this is a survey that I tried to summarize in this talk in 5 minutes. Obviously, it was not going to work. I still have 20 seconds, so do you have any questions? I'm joking, no questions. So that's it. Thank you.